Hello, my name is Alexandria Perez, and I will be leading this 3D Printing 1 workshop hosted by CPP Hyperloop and IEEE. So for today's agenda, we're first going to be kind of just going over what 3D printing is and some of its real-world applications. We'll also be kind of going over some of the 3D printing software that's used for both design and for slicing. And after that, we're kind of going to go through the printing process, starting with making a 3D object into an STL file, opening that STL file into Cura, kind of going over some of the print settings within Cura. Then we'll be moving over to the actual 3D printer, going over some of the 3D print settings, and then I'll be going over how to start the print, and at the end, we'll be having questions. So, intro to 3D printing. So, a brief overview about what 3D printing is 3D printing is a type of manufacturing process that creates a physical object from a digital model file. And the way these 3D printers work is they add layer upon layer of material to build up to a complete object. So as you can kind of see from the bottom picture, you see the nozzle building up this 3D printed object, but it starts going layer by layer. So you start with the very bottom layer, and each layer, the nozzle will go up in the z-axis, starting a new path for the new layer. And some of the real life applications of 3D printing include prototyping and product development. So one of the main reasons 3D printing was even created was to speed up this prototyping and product development process. So people were able to design whatever they wanted in any kind of design software and be able to print out their object in 3D, be able to hold it, see it, figure out any flaws with it, and with that, being able to continuously keep prototyping, designing, and further developing whatever product they've created. Another application is in the medical field. Some of the most prominent uses of 3D printing in the medical field right now is mainly in creating prosthetics. So as you can see in the picture, there's a 3D printed prosthetic hand/arm, but there's other uses in the medical field. Recently, I saw an article saying how they were using 3D printing to create real life cell models to be able to see kind of what individual cells can look like. In addition, it can also be used in construction, mostly in model building. So an architect or maybe a civil engineer can create this whole city model kind of shown in the picture below and create this modeled city or maybe even a modeled house, and then be able to 3D print that and see how it would look from a bird's eye view or even just up close. They can print individual buildings, print individual rooms, and see how they can maybe improve on this design or change things if need be. But overall, 3D printing is used a lot for manufacturing. So creating something, printing it, and continuously being able to make that 3D object. So now we're going to go into talking about some of the software used in 3D printing. So first, we're going to be going over some of the design softwares used. So there's a lot of design softwares out there to make 3D objects. Some of the more well-known ones include SolidWorks and a lot of the Autodesk ones. So in Autodesk, we have AutoCAD, Fusion 360, which is going to be the modeling that I will be using today. And there's also Tinkercad, which is free. And now we'll kind of be going into the slicing software. So what is slicing? So slicing a 3D model means that you're taking your design that you created in Fusion 360, SolidWorks, whatever, and making that into an STL file. And you can use that STL file in a slicing software to slice it into individual layers. And the slicing software can then generate a toolpath into a G-code file. And this is what the printer will use for printing. So some of the slicing software I've used is Cura and Prusa Slicer, mainly because I have a 3D printer that's from Prusa. I mainly use Cura, and both of these are also free, but I find Cura to be a lot more user-friendly and a little easier to make adjustments to the print and any other settings I'd like to change. So now we're gonna start getting into printing and from start to finish. So from creating our design all the way to getting it into the printer and getting that print to start. Alrighty, so now I will be starting the design process and creating a mini 3D print model and then converting that into an STL file that we can then put into our slicing software. So first thing I'm going to do is just design a very basic 3D model. This is using Fusion 360. So I'm just gonna build kind of just like a basic tower. So cube, and then I'll extrude it. Create another sketch on it. And extrude this as well. So now we have our 3D model. So just something basic like this, not too hard. And I'm now going to show you how to make this into an STL file. So first thing is you're going to highlight the whole thing. So now the whole thing is highlighted, and in Fusion 360, there's an object to 3D print, and this is what we'll be making this into our STL file. I made this in inches, but for Cura, it reads in millimeters when you first open the file. So I always change this to millimeter to make sure that it's the exact same size that I designed it in here when I print it. So I can uncheck this because I'm not going to be sending it directly into the slicer. So I can uncheck this, and just having the settings like I have here will give me my STL file. So if I just hit OK, it'll take me here to where I can name this. So just call this block. And I now have my STL file. Okay, so now that I have my STL file, I can now load this into Cura. So I can just hit File, Open Files, and my block STL is right here. So this is the block that I had created in Fusion 360, and it's the exact same size that I had created it. So I can move this block around throughout the builds or the print space I currently have. I have a Prusa i3 MK3 printer, and you can change whichever printer you have up here. This is the model I have, so it's what I have it saved as. And here is where you can change the material you're using. I just have general PLA, so I just have it here. But by using the move, I can kind of move this wherever. But if you move it outside the build plate, you won't get an accurate slice, and it'll kind of just give you errors if you try and slice it. But it turns yellow when it can sit on the bed in a way it can be printed. And Cura also has the option to scale. So if I think this is too big, I can cut it down by half by making it 50%. So now it's 50% of the original size, or even if I just wanted it, let's say 2 times bigger, I can make it 2 times bigger, but unfortunately I don't think it fits. So I'll be sticking to the 100. Another thing you can also do is change the rotation or kind of the position it's lying on the bed. So right now I have it facing this way, but if I wanted it to print this way, I can just turn it 90 degrees. I can turn it on the XY, and I can even turn it diagonally if I wanted to, or just kind of making it go on one side over the other. There's also an option here for selecting the face to align. So if I click on here, I can kind of click on whatever side of the build, and that will be the bottom. So some of these are a little more of the advanced settings, but for this first workshop, I'm just going to be showing the basics. So now that I have my print here ready, I can kind of start looking into some of these print settings. So in here, as you can see up here, I have normal 0.155 millimeters, 10%. This says off and this also says off. So the profiles you can change depending on what quality you're trying to have your print be. So something that you're maybe just printing just to kind of see what it will generally look like, you might want to put on a bigger space, or I guess on a different kind of setting for these profiles. The profiles indicate how far the z-axis will rise for each layer. So the smaller the size, the more fine detailed your print will be. I usually print everything at about a normal. This is a pretty good quality for the most part. So I always just leave it on the 0.155 millimeters. And down here is our infill percentage. So this will indicate how much infill to print this with. So if you wanted it to be solid, 3D printed filament all the way through, you would change this infill to 100. But that's usually not needed unless you're making something that needs to be really sturdy and robust. But even with that, somewhere between 20 to 40% would probably work just as fine. I will be printing this at 10% infill since it doesn't need too much structure and support, and it's a pretty basic print. And for these options here, will be support and adhesion. So to kind of go over the infill that I had talked about, I'm going to pre-slice this. So when I hit this slice, it'll slice this for me, give me an approximate time for it to be finished, tell me how much filament it'll use in grams and meters. And up here, so prepare is kind of just for moving everything around to see how, or to kind of fix the orientation for however you want to print it. And there's also a preview. So preview will show you the sliced file. So this would be kind of what our G-code file looks like. So you can kind of see as I kind of toggle through here, how everything kind of gets built. So it starts with a bottom layer, which you can kind of see down here. You can kind of see the path it'll take. So it'll start by creating that little outside border and then start creating the base of our model. So it'll go and fill out the whole bottom, and then each layer will keep adding. So here, these little wavy orange lines is our infill. So this is what the infill looks like at 10%. But let's say I maybe moved this all the way to 50% and I sliced it. And also usually the more settings you change in making something a bigger design or a longer design, the slicing will definitely take a lot longer when you do that. So now that I've increased the infill percentage, the time needed to complete this print should have gone up by a lot. So it went from, I think, 9 hours to 2 days, 5 hours and 40 minutes. And it's using 3 times the amount of filament. Um, so, and it's still kind of processing the layers. So now that we can see, if I zoom in, you can definitely see it's a lot more infill than at the 10%. So that's very tight knit. So 50% of it would be filled in by the PLA material. But again, I'm just going to be running this at 10%. So the slicing will be a lot quicker and it'll take a lot shorter of a time to print. So now I'm kind of going over these last two down here, the support and adhesion. Depending on how you have your design or what kind of design you have, you might need supports. So looking at this, you'd say, oh, like this red is kind of where there's no supports. But in a build like this, all I can do is flip it to a side where it doesn't have anything overhanging. So when I slice this here, there wouldn't be any need for supports. This can kind of just go and print vertically and kind of just go from top, finish that top segment, make the layer here, and then start building the smaller one out. But let's say that you have something where you can't do that. You have to have something where there's something hanging off like this. So if you have something like that, where there wouldn't be, like you can see it's red here, which means this is something that would definitely need supports. Because 3D printers kind of print that layer by layer, when it hits that segment of needing to print, if I can kind of time it right, it kind of just goes from not being there to being there. But the way 3D printers work, this isn't realistic. So what you would have to do is add supports. So if you click here, it'll generate the supports for me of wherever this would even need supports. So as you can see here, it did add a little bit of time and a bit more material, but you now have something that can support the build. So in preview is the only place you can see where the support is. If I go to prepare, you won't be able to see it. You can only see the support in preview because it will be included in that G-code file. So now, while this is all printing up, I have this kind of support following with me. And then when it gets towards the top, you can kind of see it has like a rough outline of our rectangle that would be protruding out. And you're now able to print this ledge without any worry. So as you can kind of see, the way the supports go is we have, when it kind of goes, it'll print this also layer by layer. So as the support gets its new layer, so does the rest of your build. So it's all in the same code for this layer. And now on to adhesion. So let's say that your print or your print bed isn't very sticky or it's hard for prints to stay on. Cura has this really cool option for adhesion. So when I add the adhesion and I slice this, we now have kind of an adhesive layer that adds to this. And as you'll be able to see, it's this blue lining here. So this will help make sure that our print, if it gets kind of nudged by anything or while it's printing, it has a lot less likely chance of actually getting removed off of the bed. So adhesion definitely can help with the print layer. So this would be the very first layer now. So it now adds all this adhesion around it. And it's really, this stuff is really easy to take off too. So it's sometimes worth it to just have it there, even if it uses a little bit of extra filament. But this is kind of the basis for getting everything printed in these really basic print settings. You can always kind of go into these settings and change things. Like you can change the layer height. I can be a little more specific with the values, or same with the infill. Let's say I wanted like 13%, I could change it. Cura also has a lot of different infill patterns that you can choose from. I usually just use gyroid, but that's just preference. You can change the material, speed, travel time, the supports. And usually if you kind of look up some of the more specific settings, like if I wanted to see some of the more in detailed support options, you can always kind of look it up and you'll get a lot more options to kind of play around with the settings. But for the most part, for basic prints, you really just need this stuff here. So now that I kind of have this print, I have my adhesive set up, I have supports for the build, I can now convert this into a G-code file. Alrighty, so now for converting this into a G-code file. So I personally use an SD card, which I can directly put into my printer after saving this G-code file into my removable drive. So here, this is the STL file, and I can kind of rename this if I want. This is kind of just the basic name, but I can just call this block if I wanted to, and save to removable drive. And when I do that, this saves my block G-code file into my removable drive that I can then put into the printer.
Alrighty, so now that we have that G file put in to the SD card, we can now move on to the actual 3D printer itself and kind of going over some of those settings, as well as kind of just starting the print. So this is the 3D printer. So down here, as you can see, I've put the SD card in already. So the SD card is in. I also preheated this. So right now the nozzle temperature is at 215 degrees. The bed temperature is at 60. And the Z axis is at 69.05 of its 0. So this is kind of what everything looks like. So we have the heat bed here, our nozzle here, and our filament up here, which is where it's cycling through. So going into some of the actual settings of the 3D printer, we kind of have our info screen, preheat, which is what I used earlier to preheat this. Print from SD, this will have all our SD files. We have unload and load filament. So unloading the filament will heat it up to about 215 degrees, depending on what you're using. I'm using PLA, so it's always 215. Where I then click a button, unload it, and can then load in some new filament after. And after that, we have some more of the settings. Basic settings, you can kind of like change temperature, move the axis if you want. You can stop things from happening. You can check things, kind of check crash detections, all that stuff. And calibration. So this is where you would calibrate everything. So if your Z is kind of being weird, or if your X and Y are being weird, this is where you would come to calibrate it. So you can auto home it, see where it goes, do a belt test, do a self test, which is kind of testing everything, making sure it all works. And then you have your calibrate XYZ. So calibrating XY usually isn't too hard. It kind of just moves it back and forth. But for the Z, you do have to put a little more effort into the calibration. It usually involves using a sheet of paper while the Z continuously moves down, and you kind of see, and you kind of use that to get your Z axis. It's called the paper test. There's also some mesh bed leveling and some other kind of calibrations. This is to reset all your calibrations if need be. But now for starting the actual print. So I will be going back to the print from SD. And there you can see our block.g code. So I can then select that. And for me, I personally have the setting for the bed change that I've changed myself in Cura to 63 degrees. Kind of helps with the adhesion for this one, because sometimes the prints don't always stay too much. So this is now heating this up to 63. And then on the printer itself, you can kind of see it heating up, and we kind of have some of the filament coming through. You can always kind of just move that out of the way to throw it away. But now it's kind of just waiting for it to start printing. So it's pretty much at the correct temperature it needs to be. So now it's just waiting for it to start. So now that our heating is done, the plate will move. So the 3D printer can kind of start its own calibration test before it starts the print. So kind of checking the Z axis, as you can see, calibrating it for each one. And so it'll go through all 9 points, kind of traveling throughout the bed. And when it hits this last point, it'll come all the way back to it would be, I guess, the auto home. And this printer usually prints this little line to get rid of any excess filament that may have kind of dripped out. And as you can see from here, it's now starting our print. So this is the start of the adhesion for it. But that's pretty much it. This is how you go from start to finish for 3D printing. So these are all the basics that you'll need to know. Alrighty.
Alrighty, so that concludes the end of our workshop. We'll now be taking any questions. And for anything needed, here is our email address, cppxhyperloop@gmail.com. Our Instagram is at cpp_hyperloop, and this is the Discord, the link as well as the QR code if you would like to join. Thank you everyone for coming.